Hello everyone. In this course we will learn about welding stress. The main contents of this section include 1. Classification of welding residual stress. 2. Influence of welding residual stress on welded structure. 3. Measures to reduce welding residual stress. 4. Methods to eliminate welding residual stress. The first part. The classification of welding residual stress. According to the time of stress existence, mainly divided into welding instantaneous stress and welding residual stress. Welding instantaneous stress refers to, in the welding process, a certain instantaneous welding stress, which changes with time. Welding residual stress refers to the stress remaining in the weldment after cooling after welding. The residual stress has an impact on the strength, corrosion and dimensional stability of the welded structure. It can also be divided into thermal stress, ideal stress and plastic stress according to the cause of stress. Thermal stress. During the welding process, the stress caused by the difference in the internal temperature of the weldment, so it is also called thermal stress. Phase transformation stress. During the welding process, the local metal undergoes phase transformation, and its specific volume increases or decreases the stress caused by the increase or decrease. Plastic deformation stress. The internal stress caused by the local tensile or compressive plastic deformation of the metal. The second part, the influence of welding residual stress on the welded structure. The second part is mainly reflected in the influence on the structural strength, the extraction of the machining dimensional accuracy of the components, and the influence on the stability of the compressed rod, and the rigidity and restraint of the weldment. The third part, measures to reduce the welding residual stress, is mainly from two aspects. 1. Design measures. Starting from the design of the welding structure, the methods and means to reduce the welding residual stress. 2. Process measures. After the structural design is completed, it enters the production stage, and the methods and means to reduce the welding stress are taken before welding or during the welding process. 1. Design measures. 1. Minimize the number and size of welds on the structure. 2. To avoid excessive concentration of welds, sufficient distance should be maintained between welds. 3. Adopt the joint form with less rigidity. Excessive concentration of welds not only makes the stress distribution more uneven, but also causes complex two-way or three-way stress states. The degree of restraint of the plug-in connection is larger than that of the flanging type. The bidirectional tensile stress may be generated on the weld of the former and reach a higher value. The weld of the latter is mainly longitudinal residual stress. 2. Process measures. 1. Use a reasonable assembly welding sequence and direction. As shown in the picture, first weld short welds staggered from each other, and then weld straight through long welds. The weld with the largest shrinkage should be welded first, because the weld that is welded first is less hindered when shrinking, so the residual stress is relatively small. For the situation in the picture, because the shrinkage of the butt weld is larger than that of the fillet weld, the butt weld 1 on the cover plate should be welded first. And then the fillet weld 2 between the cover plate and the 1 beam should be welded. The structure shown in the picture is the intersection of the butt weld and the fillet weld. The welding sequence should be: butt weld 1 has a large lateral shrinkage, and must be welded first, followed by fillet weld 2. On the contrary, if the fillet weld 2 is welded first, then when the butt joint 1 is welded, its lateral shrinkage is not free, and cracks are easily generated. 2. Preheating method. The preheating method is to preheat the weldment locally or as a whole to 150 to 650 before welding. The preheating method is often used for welding or repairing weldments of materials with a greater tendency to harden, as well as weldments of rigid or brittle materials. 3. Reduce the degree of restraint of the weld. The closed weld of the panel on the flat plate has a large degree of restraint during welding, and the longitudinal and transverse tensile stress of the weld after welding are high, and cracks are easily generated. In order to reduce residual stress, try to reduce the degree of restraint of the closed weld. 4. Heating, reduced strain zone method. The diagram shown in the figure is the schematic diagram of the reduced strain zone method of heating. The left side is the adding process, and the right side is the cooling process. At the strain relief zone before welding, the fracture gap increases. First, large. Then, welding. Last, stop heating the strain reduction area after welding. The welding seam in the heating areas on both sides cool and shrink at the same time, without hindering each other. The fourth part, the method of eliminating welding residual stress. The first method is heat treatment method. Using the yield point drop and creep phenomenon of the material at high temperature to achieve the purpose of relaxing the welding residual stress. There are two kinds of heat treatment methods commonly used in production: overall heat treatment and local heat treatment. The second method is the mechanical stretching method. The mechanical stretching method applies a certain tensile stress to the component in different ways, so that the weld and its vicinity produce tensile plastic deformation, which is different from the weld and its surrounding during welding. The compressive plastic deformations generated nearby cancel out a part of each other to achieve the purpose of relaxing the residual stress. The third method is the temperature difference stretching method. The metal on both sides is heated and expanded to stretch the area with lower temperature, so that part of the residual stress can be eliminated. It is determined that the effect of eliminating residual stress can reach 50% to 70%. The fourth method, hammering the weld. After welding, hammering the weld with a hand hammer or a hemispherical windhammer of a certain diameter can cause the weld metal to extend and deform, which can offset a part of the compressive plastic deformation and reduce the damage. The effect of small welding stress. The fifth method, vibration method, also known as vibration aging or vibration stress relief method. It uses an exciter composed of an eccentric wheel and a variable speed motor to reduce the internal stress by the cyclic stress generated by the resonance of the structure. This is the end of this lesson. Thank you for watching.